Hi everyone, welcome back to our channel, Los Chicos del Rincón. And now we're presenting our physics final project. Well, my team is confirmed by Raúl Alejandro Estrada and me, your server, Emiliano Martinez Corona. So here we have the index. So we're going to discuss some topics, which are work, kinetic energy, and gravitational potential energy. And at last but not least, law of conservation of energy. So about all these topics, we're going to give a brief explication about them, and then we're going to see a problem and how to solve them. So let's get started with it.
Okay, so first of all, we have the work. I know that is something kind of difficult to understand because when we used to think in work, of course, that we imagine someone at the office or doing something that is not comfortable, but it's not in that way. Here, talking about in physics, the work is the energy transfers that occurs when an object is moved over distance by the external force. What does this mean? Well, that is when you apply a force or you're applying a force to an object. That's it. To express this concept mathematically in a mathematical way, that is the language of the nature. We're going to have that the work is equal to W, and this is uh, the force times the distance. And here we have the formula. And we have also particular thing that is that if we have an angle, this is going to be the same formula, but multiplied by the cosine of the angle.
So here we see the problem, where an object in movement is moved by a force or a tension. Here we have the free body diagram where we can see all the forces acting in this box. So we can see the friction of the kinetic friction. Here we can see the normal force and the weight. So and at least the force. But here we have another two forces. This is the force. But here, if we divide it, we have here a force in X and here another force in Y. So let's start with the procedure. Well, let's read first the problem. It says, according to the following figure and the data provided, how much work does the kinetic friction do? Here we have some data that the force applied is of 40 newtons, the frictional force is of 10 newtons, the mass is 3 kilograms, and X, which is this base, is of 8 meters. So let's see. Here we have the sum of forces in Y. So as I told you, all the forces acting in the coordinate plane in Y are the normal force plus the force in Y minus the weight. This is equal to 0. So if we analyze the formula, we get to this, that the normal force is equal to 40, which is the force, newtons, times sine of 20, because all the force isn't applied, just this. And then here we have the weight. So we get that the normal force is of 15.72 newtons in the, well, this is the normal force. And we needed to calculate this part of the sum of forces in Fx. So here we have the forces of the force in X minus the friction is equal to force net. So here we have all the procedure the same, 40 newtons times cosine of 20 minus 10, which is the frictional force, is equal to 0. So here we have, this is the force and this is the frictional force. So as we can see, the force is bigger, way bigger. So all the frictional force is applied, which is minus 10 newtons. So the only thing we have left to do is to convert the newtons to joules. So here we have the conversion, minus 10 newtons times 8 meters to make newton meters is multiplied by 1 joule, that is equal to 1 Newton meter. So we have that the force applied of the frictional force is equal to minus 80 joules.
Well, trying to summarize this, we are converting this to joules because the joule is the main measure of the work that in this case, as we explained to you, is the force applied. Then we're going to talk about the kinetic energy and gravitational potential energy. Try to explain kinetic energy. It's like kind of difficult because are like abstract concepts. The kinetic energy is basically the energy, well, the movement that we can see into a car. If a car is moving, there we have kinetic energy. That is when you have movement. Then we have the potential energy. That is basically, and trying to summarize, the opposite of the kinetic energy is the capacity that the object is stored because of their position or state is energy that's stored basically, but there's no motion in it. The formulas present for the potential energy are gravity is equal to m, that is mass, times gravity times the height. So with these values, we can get the potential energy, the capacity that an object stores in the room. And at least we have the formulas for the kinetic energy. That is basically kinetic energy is equal to half times mass times square volume. Well, and here we have the problem that says a 5.21 kilograms box is placed on an 80 centimeters table. What is the potential energy of the box? It is on the table. Well, so here we have
Careful, careful, mate. Well, he gets back. We have that the formula of this is mass times gravity times height. So here we can see all the values replaced, and we get to this result, which is 40.84. So let's see if our mate can continue with the explanation.
okay. So in this case, as we told you, the potential energy is going to be the mass times gravity times height. Well, the mass of the object is 5.21 kilograms. That is going to be multiplied by the gravity, that here is 9.8, by also the height, that is zero point 0.8. So in order to get the result, we multiply all of these. As you remember, it doesn't matter the order, and the result is the one you saw there.
Well, and at last, we have the law of conservation of energy that establishes that the law of conservation of energy states that the energy can neither be created nor destroyed, only converted from one form to energy to another. This is very similar to the statement about the materia, where it says that it can be created or destroyed, only transformed. And this shows us or try to say us that everything always is going to have the same amount of energy, like, and you can only convert it from like mechanic energy to thermal energy or the other side and cancel and all that things. So
Okay, well, this is one of the most important because it's present in all the things that involves nature. Because as you remember, all what happened, all the creation was uh, a small concentration, a huge concentration of energy that was in a small point. So in order to have all what we have nowadays, all that energy get converted into other things, and that's why it's one of the most important things right now and nowadays.
So in here we have a problem which says a ball of mass of 284 grams or 0.284 kilograms falls freely from a table of a height of 53.4 centimeters or 0.534 centimeters. So it says, at what speed does the ball hit the ground? So here we have a specific formula for that. Well, we have to get, this is the formula. Final velocity squared is equal to initial velocity squared plus 2 times gravity times
The displacement.
displacement in y. So here we have that the initial velocity is 0 because it's a free fall, and the free fall always starts with a velocity of 0. And here we only substitute the values we already have and get this, that the final velocity is equal to 3.235 meters per second. This formula is very simple. We only had to substitute all the values. So that would be everything, if I'm not wrong, mate.
Yeah, from our part is uh, almost everything. We hope that you enjoyed this class a lot. For us was a very huge challenge to trying to adapt this for you, but all the work, I think, and all the job that involves this explanation for us is how can you define it, Emiliano?
Yes.
It's a pleasure.
Well, it's a pleasure like being with you and trying to give our best. So thank you and see you.